experiment, we're going to be doing gravimetric analysis. What that entails, we'll talk about later in the presentation. So the objectives are, number one, to define what a hydrate is, to determine what the goal of this experiment is, and we're going to talk about that. And then I'll also tell you about what you'll need to do the experiment. So what is a hydrate? A hydrate is any metal salt that has water coordinated to it. And if you look here, the metal is in green, and then this particular metal has 6 water molecules coordinated to it. If you know the boiling point of water, which is 100 degrees, if you heat the hydrate past 100, then it's possible to dehydrate it and drive off the water. So if you heat it, if you continue to heat it, you're going to get the anhydrous salt, which is located here as MX, and then you would have driven off 6 molecules of water. So what are we going to be doing in lab? We're going to start with a metal hydrate, and then we're going to heat that metal hydrate for a period of time. We're going to determine how much water we drove off, and we're also going to determine the ratio of water to metal salt in the hydrate. So let's look at it. Here are a couple of things to remember. Number one, don't forget to dry your crucible. Those crucibles are made of this ceramic material. It's really porous, so it absorbs water. So you're going to have to heat the crucible up to dry it and drive off any water that's in it so you can get an accurate measurement of the mass of the crucible. You also don't want to forget to weigh your material and then weigh the dry crucible. And don't touch anything with your bare hands because we're going to be using Bunsen burners to heat the crucibles, and they're ceramic and they get really hot. And also don't forget to weigh the sum of the crucible as well as the material. So here's the experimental setup, and this stuff, as I said earlier, it gets really hot. So here's your ring stand, the Bunsen burner, the crucible. You're going to need a clay triangle or a screed, and an iron ring. And this is the basic setup to do gravimetric analysis. And if you'll notice, the crucible has, if you look at the lid on the crucible here, it has a little bit of a gap in it, and that's to allow the water to escape. So while you're heating this, you don't want to cover the crucible totally, because if you do, then your water, as it evaporates, it's just going to go to the top and then drip back down into your sample, and you don't want that. You want to leave it cracked so you'll give that water a chance to escape as steam. All right, so how are we going to calculate the amount of water that we lost? We're going to first weigh the crucible plus the hydrate, and then we're going to heat that crucible plus hydrate to drive off the water. And after the heating, we're going to weigh the crucible plus the salt after we heated it, and we take the difference. It's that simple. So over here you have a little equation where the mass of the crucible plus the hydrate and minus the mass of the crucible plus the anhydrous salt after you heat it, it'll give you the mass of water that was driven off. All right. Once you know the mass of water, it's a fairly simple exercise to determine what percentage of water was in that hydrate. Right. So what is the formula of the hydrate? We can figure out how much water we drove off. So how do we figure this out? How do we figure out the formula of the hydrate? First, we need the molar mass of the salt. After heating, obviously, we need the molar mass of water. We need the number of grams of water driven off, and we need the number of grams of salt left over. Knowing these pieces of data will help us to determine what the formula for the hydrate is. So here's a sample. We have a 50-gram sample of copper sulfate, and it's a hydrate, and we heat it in a crucible. When the sample was reweighed, it was found that the mass of the sample was 37 grams. How much water was lost? So let's look at it. So if we take the difference, we started with 50 grams of the hydrate, and we ended up with 37 grams of anhydrous salt. That means we lost 13 grams of water, right? And knowing that helps us to determine the other pieces of data that we need. So the next question asks, what's the ratio of salt to water in the hydrate? Well, if we know that 13 grams of water, and we know the molecular weight or the molar mass of water, which is 18 grams per mole, we can determine how much water we got from that. And then if we know 37 grams of the anhydrous salt, if we know the molar mass of the anhydrous salt, we can determine how many moles of anhydrous salt we have. And then the ratio of salt to water is the moles of water divided by the moles of anhydrous salt, right? So that's how we determine that ratio. from that we can write the molecular formula for the hydrate.